Hello, welcome to another problem session. So this is a problem about beats, uh, and beats are the phenomena of all waves. It should be in waves, whether you have electromagnetic waves or sound waves or some other types of waves. A beat is a very natural consequence that you'll see in those waves if you set the things right. Okay, so what is the setup here? We have same key on two pianos. It's like on the right, all the way to the right, that's the very high pitch key. And then it's supposed to be close to here, it's a little bit higher than this, but this is fine. This is supposed to be, and they're not perfectly tuned, and one is gonna be at that and another one's gonna be like that. A hertz, so if you know, hertz is a unit which is cycles per second. And when the two piano keys are placed at the same time, you hit them at the same time, or you hit and hold the pedal, and other one, then you hit the other piano and hold the pedal. So you're holding the key sound, okay, and they're vibrating and they're producing the sound, and sound is coming to your ears at the same time. And so those, either you think in terms of displacement wave or pressure wave. The net total will be the sum of the two waves. So and the net total, what you hear is this. So you have a either you have a psi 1 xt and psi 2 xt, which is, this can be delta x wave or delta p wave. This can be same delta x wave or delta p wave. There are two ways to think in terms of sound, right? And so the net will be just sum of this thing, sum 1 xt plus psi 2 xt. And the reason it's going to be sum is called superposition principle. This name of this sum is called superposition principle. It's due to superposition. Why that's going to work? It's because these guys obey a linear differential equation. So these obey a linear differential equation. That's why. So they if this is the sum, the solution will be the sum, and it looks like d square psi dt square 1 over velocity square d square psi is not over v, it's going to be 1 over v square over here, dx square. And if you're three dimension, you can have a similar one for y and z. And because psi is 1 power, it is linear. So that's the upshot of where it comes from. And this is the one you're going to hear. This is showing up as something close to, so you only hear, so this will look like this will look like this. And actually, and then this is going to repeat. It's going to, this has been much more rapid. It's going to look like this. And so there is a period associated with, so there is a, this is a period. So this is called carry period. a signal period. Well, I'm doing this is what you will hear. Okay, and then there is a loud to loud or soft to soft. So this is the period called beat period. So this is in time. You're gonna hear you're gonna get a signal like this in your ear. Okay, that's what this question is. So you originally have this and this, but you actually gonna hear this period, and the sound you're gonna hear is going to be at sometimes loud, and then gradually gets soft, and then it's gonna become loud again and soft again, and that's the beat phenomena. So this is the beat phenomena. Okay, so if you work out the math, the answer you're gonna find, I'm gonna write the answer, and sometimes the formulas are very easy. So if this one has a frequency f1 and this one has frequency f2, so this is a frequency, those are frequency given this and that, then this frequency for this carrier wave, this wave, okay, so here let me write down heard frequency is actually average of the two, f1 plus f2 over 2, and beat frequency, not beat period, is going to be difference of the two, and doesn't matter, you just take absolute value because it's positive. Of course, beat period will be just the period will be 1 over beat frequency. So these are the formulas that you can just apply. These formulas are derived in my book, so you want to check this formula derivation. I might do it at the end of this video if it doesn't take too long. So derivation is in www.physicsbootcamp.org, and I'll clean it up and give you the numerical answer, and then if time permitting, I will drive these formulas for you. Okay, so let's finish up this answer. So one would be, answer to one simply will be f that's gonna here is f1 plus f2 over 2, which is 1046.2 plus 1046.6 over 2, which is 1046.4 hertz. This is close enough, close to 1046.5. And f beat will be not difference divided by 2, just the difference. And there's a reason why that's just the difference. And when you see the derivation, you will know why. Okay. And this is going to be 1046.2 minus 1046.6. So difference is 0.4 hertz. But we want period. So t beat is 1 over f beat. It could be 1 over 0.4, and this is hertz, so this will be second. And you can say 10 over 4 equals 2.5 seconds. So you're gonna get pretty this is gonna vary very rapidly it's gonna get. And between here and here will be 2.5 seconds, and these guys will be, the time will be inverse of that. So you can see 1 over t that's gonna here is 1 over 1046.6 seconds. So the 1 millisecond, this is around 1 millisecond you're gonna hear. This gonna, time period for this will be 1 millisecond, time period will be 2.5 seconds. Okay, so these are the answers. Now let's look at a model in which we can produce these formulas. So there will be a model. We're going to model this. We're not going to do the piano key and things like that. That's a we're going to think of a math situation in which everything is simpler and works out nicely. Okay, so the math situation we're going to think about is is both of these signals is going in that same, so wave 1 is going this way and wave 2 is going that way, and over here is our ear, a detector. So this wave is that and this wave is that and has that frequency. So we're gonna model, we're gonna say they have the same amplitude. Okay, amplitude will be half of that, amplitude will be half of that, simply for simplicity. And we're gonna take this as an x-axis, or maybe this is x equal to 0 where I'm gonna detect it. Okay, so we have psi 1 representation of this as, and we can also think of this as a plane wave. And we've talked about this in earlier video. So xt will look like sum a cosine k1x minus omega 1t, and I'm gonna also just suppress phi's. So phi 1 equals to phi 2 equal to 0. I'm just gonna set this. It's not necessary, but just gonna get rid of that just for simplicity. So this is same as that. So if you remember, omega 1 is going to be 2 pi f1 and omega 2 is 2 pi f2. Okay, so the net psi is going to be the sum of these two guys, and so you have a this is psi 1 plus psi 2, and let's work this out. So psi is psi at x and t, so any point where they're overlapping will be just a is common, and so this is like a cosine theta 1 and this is theta 2. So a cosine theta 1 plus cosine theta 2. And when you have a cosine theta 1 plus cosine theta 2, you probably know the cosine A plus cosine B formula, right? So this should be equal to A times 2 cosine theta 1 plus theta 2 over 2 cosine theta 1 minus theta 2 over 2. And so this is 2 times A cosine, you can see in here, and we want at x equal to 0. So we want amplitude at x equal to 0, at x equal to 0. So let's simplify that even more. So if x equal to x go away, so this omega 1 plus omega 2 over 2t, and this one is cosine omega 1 minus omega 2 over 2 t 2t, and this is psi at 0 t. That's where I'm detector is here, like your ear. Now this is the amplitude. So you can see that you are going to you're going to see this is the f1 plus f2 over 2, guys, and this is, there's a 2 down here. So why there is a 2 down there? Well, let's convert this 2 into intensity. That's what I'm going to hear. So this is here, I'm going to, what we hear is not the amplitude per se, but intensity. That's what we perceive. So intensity would be proportional to, you remember that proportional to psi of 0t square. And we have to average, time average. So we are going to time, when we time average, we are not really time averaging over everything, but this is a concept that needs a little more discussion. But just let's look at what's, if I square it, and we get so we have a 4a square. We can just proportional, so we just forget that 4a square. So this is proportional still. It's going to be cosine. This part is going to be actual signal. When you average it out, is square of that is going to be it will riddle into half, and then its intensity is going to vary. This would not get averaged out. So average over fast damage or fast signal. So they would be average out half, and so this will become cosine square omega 1 minus omega 2 over 2t. The signal will vary with time. Even if I've time averaged, I'm time averaged only fast signals. My eardrum will get average out only fast signals, and the average of this will just give me half. So this one, if we look at what is the period of this thing, this is where the beat will come from. Period of this function of frequency, let's call it frequency of this function, is actually, because square, you can convert this to so cosine square, say theta is double angle, right? So 1 plus cosine 2 theta over 2. So this is the one that's varying. So if you look at that, 2 times that, this will act like cosine 2 times omega 1 minus omega 2 over 2t, and this 2 cancels out, and this is where the period of frequency of this, or angular frequency of this, will be omega 1 minus omega 2. Hence beat frequency is equal to f1 minus f2, and this one is the fast frequency, and that's obvious. I don't need to explain that. But the beat frequency, why there's no 2 there, is because when I'm averaging over fast signal, faster part of the there are two variations here. This is one variation and this is another variation. This is way faster than this, so this will get averaged out to half when I do the intensity square and time average. So intensity is always time average, but when you have two time scales in your problem, you have to think about which time is going to be averaged out and which will not. Okay, so I'm going to stop here. Hopefully this clears up some of the questions you might have about beat frequency, how the half got disappeared, and things like that. When I was learning, this was always a problem. This particular thing was very challenging to me when I was learning, and I will suggest go out and expand and do this yourself. Time average over only this frequency. So when you're time averaging, you can you can time average. You remember 0 to minus t over 2 over t over 2. If you have time averaging some periodic signal, then I need to decide about the period, and you think about this a little bit more, and maybe this will make sense. Okay, talk to you later. Bye.